Good afternoon, everyone. Welcome to virtual learning session number 4 with Miss Freeland. I know this is not the ideal situation we were hoping to come back to after spring break, but it is what it is, and I know all of you can do such an amazing job while we are in our distance learning, and I'm fully confident that we will make the best of this crazy situation and truly come out for the better. Today, our math assignment is Unit 8, Lesson number 1. So you're going to need your homework and remembering packet from your yellow folder, and we're going to take a look at 8-1 about points, lines, rays, and angles. And you'll also need your math spiral notebook for some notes today. So grab a pencil, gather up those materials, and come back ready to go. All right. Hopefully you were able to find everything that you needed and are ready to take a few notes today. I will be honest, this first lesson has a lot of notes to take, and we are going to make a quick little chart, but feel free to stop and start the video as often as you need to so that you can get everything written down in your notebook so that you can be extremely successful with today's assignment. So at the top, I am going to start with Unit 8. Geometry. I know before we left on vacation, we had Units 5 and Unit 8 left to do. Mrs. Wash and I made the executive decision to jump into Unit 8 instead of 5 because this is kind of an easier unit for us to do virtually. First thing I want to say is if you do need support from our textbook, page 273 is where you can find some support for this instruction. We are going to look at a picture. I'm going to call it an image. And then I'm going to describe it or define it over here. So we're going to make a quick little T-chart, some quick drawings. You might want to find, a little ruler for yourself. I'm just going to kind of freehand it and go from there. And we'll do this kind of quickly. So the first image that we're going to talk about is going to be extremely simple. And there it is. Yep, that's a dot. I literally drew a dot. And next to it, I am going to write the letter M. That's for Mindy. It's my first name. You can name it anything you'd like to. If you'd like to use the first letter of your first name, please go right ahead. But to name this, if we were going to talk about that image that we just draw, we would actually say that that is point M. And that's what we classify it as in a geometry unit. By definition, a point is shown by a dot, a simple little dot, on a line segment, which we'll define in a second here, ray or angle. We use points actually to give lines, line segments, rays, angles. We use them to name what we're talking about in a geometric figure. So that if we were discussing something, we could discuss it by using its name, just like I would say Cole or Cal or Liam. We would use point M, point N, calling it by name. And we label with a capital letter. We often don't use lowercase letters because they get a little confusing with some of our numbers. So from there, I'm going to just draw a horizontal line and go on to our next image. So our next one, again, you may or may not have seen this before. It's a straight. On either of its ends, I'm going to put some arrowheads. And within that image, I'm going to put 2 points And I'm going to label this M and J. Mindy, my first name, J for Joy, my middle name. To talk about this, we would say that this is line MJ. If we were showing someone line MJ, we could use a symbol with the line symbol above and the initials MJ written below. So we call this a line, and by definition, a line is a straight path that goes on forever. And that is a key. It could continue on forever in both directions, hence the endpoints being arrows. As indicated. By arrows at both ends. To give this line a name, we name using points on the line. In this case, line, arrows on both ends, indicating that it could go on in this direction forever, or it could go on up and across my page in that direction forever. A line is intended to be drawn and displayed so that it could potentially continue on in either or both directions forever. Drawing a little horizontal line. I don't want to call it the opposite, but something different from a line, or another geometry term that we're going to talk about, is what we call a line segment. The difference between a line and a line segment, where the line could continue on in either direction, a line segment really has definitive endpoints. It starts and stops in a very specific location. So similar to what I've drawn up there, I'm going to draw just the segment of the line that I have above. I can name this also M and J using those labels once again, but noticing how it does not continue with arrows in either direction. It definitely has a start and a stop, or vice versa. It could start here and stop there. We call this a line segment. We would say line segment, sorry, that ran over there, MJ. And if we needed to label it, it would seriously be just a straight line with MJ or JM written below it. By definition, a line segment is only part of a line. It is a straight path that has two endpoints. We consider those a distinct start and stop, meaning that the line segment goes no further than those endpoints. We name using the start and stop points. Okay, so just kind of cruising through. Sorry, I'll adjust that a little bit. So we have points, okay, simply a dot, if you will, labeled with a letter. They are always on a line segment, ray, or angle, and we use them kind of to discuss them and to talk about that point, that shape, that line segment, ray, or angle. We have a line that is a straight path that will continue on forever in both directions. We use those points on that line to give it a name and refer to it by its name. We also have a line segment, which is only part of a longer line. We again use points on that line segment so that we can name it, refer to it, and talk about or discuss it. The last little piece of the puzzle kind of combines both a line segment and a line. And this one is called a ray. By definition, we'll discuss the ray in just a second here. By definition, you have a definitive starting point. So it is going to start in one point or one location, but then it's going to travel in a straight path and potentially continue on in that path. Sorry, I didn't realize I was writing out of camera. So the ray has a definitive starting point, travels in a single direction in a straight path, and we indicate that that path could continue with an arrow on that end. We can put another point on this ray, and I'm going to indicate this is point M, the starting point. It travels through J, another point on the ray, but could continue up and across the paper. Again, when talking about this, we would say that this is ray MJ. And to draw a symbol for it, we would draw a quick ray with the letters M and J beneath it. So by definition, and kind of to a review, a ray is a straight path that begins at a single point we'll say that begins at an endpoint. Well, I might want to capitalize that. Did before, so I might as well stay consistent. And it will continue forever, as indicated by the arrow, in a single direction. We name using the endpoint and another point on the ray. Okay. So using these four different terms, point, line segment, and ray, we can put these very basic geometric terms, these very basic geometric figures, we can put them together to create all of our other shapes. We can put them together to create angles. We can put them together to create triangles, quadrilaterals, hexagons, pentagons. We can put all of this information together and create all of our other geometric shapes. Today we're starting really just with the basics, okay? One more thing that you will need to know are our angles. Technically, we have 4 different angles that we're going to use here in the 4th grade and that we're going to talk about and discuss. So I have some extra space here at the bottom. You don't need a lot of space. You too should have some room there at the bottom. I'm going to quickly divide it into 4. So I like to do half, and then half again, and half again. And that should give us enough room, if we're doing this neatly and petitely, like we've always practiced, should give us enough room to talk about angles. Now, the angles that we're talking about and the angles that we're discussing, we really could use lines, line segments, or rays to create all 4 of our different types of angles. So I'm going to try to incorporate everything that we talked about above as I draw these various examples. But please know, these are just examples, and they could be drawn using any of those lines, line segments, or rays. So an angle combines two lines, line segments, or rays. Okay. These 4 different types of angles that we could create fall into the category of an acute angle, ACUTE, a right angle, an obtuse angle, or a straight angle. Now, if you remember anything about geometry from your earlier grades, probably around 2nd grade, one of your 2nd grade teachers may or may not have discussed that these angles have what we call degrees. We measure angles like the degrees of a circle. Where a whole circle has 360 degrees, these angles all have a smaller unit of measure. We would take 4 right angles to make up a total of 360 to make a total circle. Right angles is kind of our foundation. A right angle measures exactly 90 degrees. We use that little circle symbol to show degrees. It measures exactly 90 degrees. No more, no less. It is an exact measurement. We often say that it goes straight across side to side, and it goes straight up and down. Sometimes we call this this vertex where they meet a square corner, and we indicate that by putting a small square in the corner, saying that my drawing is the best that I could do, and I'm indicating a 90-degree exact angle by using that square. Using what we talked about up at the top, I'm going to make this 2 rays and put some points on it. And let's use my initials just because I know them, MJF. So we would say that this was angle MJF, and it equals 90 degrees. Moving to the left, acute angles are any angle that measures less than 90 degrees, but more than nothing. So we say that acute angles are anything from 1 degree, very teeny, very tiny, very small, to 89 degrees. Because the minute we go to 90, we now have a different type of angle. It is a right angle. Acutes are those teeny tiny ones. So using kind of that similar drawing, if we do a flat horizontal piece here, I'm not going to go straight up because that would be a 90-degree angle. I'm going to close it a little closer, and I'm going to go in. And I'm going to make these 2 line segments. Okay, and we're going to say that in here, this space being less than 90 degrees would be an acute angle. Again, I'll use my initials, M, J, F, and we would again label this as angle M, J, F. In some of our upcoming units, not while we're virtual, but a little later on when we return face-to-face, we'll actually talk about how we measure these angles and how we use a tool called a protractor to actually find the exact number of degrees from 1 to 89 that this angle would actually measure. How far it goes from 0 up to measuring that other line segment. Okay. Now on the flip side, going from a right angle to a straight angle, the obtuse angles kind of fall in the middle. Similar to acute, these measure 91 degrees, just shy of that 90, all the way up to 179 degrees. Anybody care to take a guess what a straight angle measures? Yep, you guessed it. One more degree. It's a 180 degree. So to draw an obtuse angle, we continue with that flat segment there. And I think I'll draw a line segment. And this time I'll draw a ray going this way. But instead of going straight up like that 90-degree angle does, this one kind of opens wider. He kind of opens out. He is definitely a big open angle. We consider these obtuse. Again, labeling them. This would again be angle MJF, but he would be an obtuse angle, measuring past that 90 degrees, opening up into kind of this larger area outside and past that 90 degrees. A straight angle is exactly that. We go into an endpoint and out from the endpoint, and we could do the same thing with points on the line. Using my initials, we have angle MJF. Starts over here, opens all the way up, and continues on in the opposite direction, making it a straight line segment. So hopefully with that discussion and with the help of some of the other videos that I've shared and the help of your textbook where all of this is again laid out, you should be pretty successful in completing your assignment today. You are being assigned all of the questions on the front of 8-1 and all of the questions on the back. So the first part, draw an example of each. So draw me a point, draw me a ray, draw me an angle. Question 4, name the angle shown. For this angle right here, what would you give it? What name would you give this angle here? Look at the angles below. We have angle PAV, angles MT and Z, and how would you classify them? Which of these angles are right angles? We would say angle this and this. Which of them are acute, those small, cute little cuddly angles? Or which of them are obtuse, those big, larger angles measuring past that 90 degrees? Feel free to take your paper and kind of turn it, move it, look at them, do whatever you need to do to get a good eye on those angles and try to figure out as best you can what needs to be done. If you have questions, remember, reach out, contact me. I'll be here all day. Feel free to ask. And remember, when this is finished, don't tear it out of your packet. Just keep it in your packet, and we will collect it when we return face-to-face. Thank you very much. Hope you enjoy watching the video, and we will talk to you soon. Enjoy geometry. Bye.